Alrighty, folks, we are going to take a look at 11.2, day one. Yesterday, we learned how to find limits, meaning what the graph is approaching by using direct substitution. We also used graphing. We also was a value function, and then we also used graphing, but then the table function. So long term, that's not the most effective way, and we want to find some algebra ways, math ways to figure it out so that we can be more efficient. Finding the limit is something you're going to do pretty significantly, or frequently, I should say, in calculus. You're going to notice that this is going to require you or expect you to remember a lot of the skills that we learned along the way. Factoring, rationalizing, working with stacked fractions. Those are just going to be like tiny little steps in bigger problems. And that's why we kind of go over those things a lot in pre-calc in hopes that when you get to calculus, you're not stumbling over those pieces rather than being able to focus on the actual calculus. So, like yesterday in this first one, the 3 is a problem, the negative 3, I should say, because when I put a negative 3 into the bottom, it's going to create a 0, and then I'm not able to do anything from there. So, one of the ways that we try to break things down with limits is we kind of factor and cancel. So, if I look at the top and I think, how do I make 6 in a way that subtracts to be 1? I can factor the top into 3 times 2. In order to get a positive 1, I'll need a positive 3 and a negative 2. And then the denominator is still x plus 3. So I haven't changed anything. I'm going to leave myself a little more room here. I still am looking for the limit as x goes to negative 3. And the function hasn't changed. I've just rewritten it mathematically. But then these are the same, so they cancel. So ultimately, that question is, what's the limit as x goes to negative 3 of x minus 2? So now I can go ahead and use that direct substitution from yesterday, put the negative 3 in for x without any issues, and find out that my limit is going to be a negative 5. So easy, super slick. So always watch for that option to kind of factor and cancel. Dividing out technique is really the same as factoring and cancel. So rather than doing long division or synthetic division, I'm just trying to factor it and break it down if I can. All right, so in this example, same thing. This can be tricky, but I'm going to split this into 2 pieces because it's got 4 parts, and so I'm going to use factoring by grouping. So the top stays the same, and I'm still looking for the limit as x goes to 1. The 1 in the bottom would have created a 0, and then a 0 at the top as well, so it's not going to help me. So I'm going to go ahead. I'm assuming that I will find an x minus 1 in the bottom as one of the factors because I need it to cancel in order to do this problem. So let's revisit, how do you do grouping? You split it in half, and then you look for the greatest common factor for this half. So in this case, that would be an x squared, leaving me with x minus 1. This side doesn't have anything, but it has the x minus 1. So what happens now is I look at this piece and find out what they have in common and take that out in front as the greatest common factor. Now this doesn't look like there's anything left there, but keep in mind that if it doesn't have a coefficient in front, it's the same as having a 1. So when I take these out in front, my other factor becomes x squared plus 1 from these remaining pieces. So again, that's factoring by grouping. You've done it a zillion times, but now it's kind of coming up in this pre-calc stuff where you're going to be needing to use it as a step in your calculus problems. These are the same, so they cancel. So ultimately, my problem becomes the limit as x approaches 1 of 1, since I canceled everything, over x squared plus 1. And now it's not a problem. Now I can put that 1 in there. I'll end up with 1 over 1 squared plus 1, or 1 half. So the limit of that function is going to be 1 half. Okay, so now I'm going to need to look at another technique because this one has square roots in it and there's nothing to factor. I really can only factor if I have a higher power of x, and I don't. So again, putting 0 in the bottom is going to be a problem, so I can't just use direct substitution right from the start. So we're going to rationalize. And again, this is something we've done a lot, but we've always kind of just done it just to do it. What you have to use is the conjugate, and the conjugate changes this middle sign. So because that's a minus, I'm going to use a plus. Whatever I do to the top, I'm going to do to the bottom. So we have done this, but We just sort of did it without an end purpose. Now we need to really focus on it as a part of our bigger picture. So I'm going to FOIL. These two look terrifying, but really the square roots just cancel out. So I end up with an x plus 1 there. Here, I would get a root x plus 1, and then on the inside, because see here I would have square root of x plus 1, but then on the inside I'd end up with a negative one of those. So thankfully those are going to cancel out, which was the whole idea. And then for the final one, the last terms will be a minus 1. So just focusing on the top for now, and honestly, I don't multiply out the bottom because I'm going to be later on looking for things to cancel, and it'll be easier to see them if I leave that bottom in factored form. I'm just trying to take care of the roots on the top. So these have thankfully canceled because I chose conjugates, and then I'd have x plus 1 minus 1, so that actually cancels. So at this stage, I have an x left on the top, but then I have an x sitting out in front of this part. So that cancels as well. So once I'm done with all that simplifying, I end up with limit as x goes to 0 of 1, because I canceled everything off the top, over the square root of x plus 1 and then plus 1. So now I can go ahead and put in my 0 because I'll end up with 1 over the square root of 1 plus 1, or 1 over 2 again. So finding a limit is easy once you can do the direct substitution. It's just recognizing and knowing what to do. But in your homework, it's going to be very much the same thing. If it's got squares or cubes, you're probably looking at breaking it down, factoring, and canceling. If it has square roots, you absolutely are rationalizing. So look back at your notes and follow these steps. And if you get one of these lovely gems at the bottom, the stacked fractions, we've done these problems. You did them in Algebra 2 briefly. We've done them in our class. And so now that skill that we learned is going to be a part of the bigger picture. Putting in a 2 makes that bottom a 0, not okay. The other thing that's not okay is my pencil's not sharp. Let's trade that sucker in. Okay, this other one's not sharp either. All right, we'll just go with it. So the bottom is good to go, but, and the reason is it's not a fraction. The top is 2 separate fractions, and I need them to be 1. I can't have 2 fractions on the top. I have to get them to be 1 fraction. And in order to do that, I need a common denominator. So these are my 2 pieces. I'm going to end up really just having to multiply them together to get a common denominator. This 1 is already over the x plus 2 part, but not the 4 part. So it would turn into a 4 because I'd have to multiply it by a 4. Then this negative 1 is already over the 4, so it has to be multiplied by the x plus 2 part. So just kind of dragging this bottom part along for now, since I don't have to do anything with it, and dragging this denominator along. What I need to do up here is distribute the negative. So I end up with 4 minus x minus 2. So I'm really just trying to simplify this. So putting the like terms together, I'm going to have a negative x and then a plus 2 over 4 and then x plus 2, still all over x minus 2, which isn't over anything, so technically it's over 1. So we're still looking to simplify this down, and nothing is canceled. We're going to ultimately take, remember with stacked fractions, the top times the reciprocal of the bottom. So I'm going to end up with this top fraction multiplied by the reciprocal of this, which would be 1 over x minus 2. Now I need something to cancel. This doesn't really cancel because of the negative. That doesn't cancel either. That negative x is what's messing everything up. So I'm going to go ahead and take a negative 1 out of this top part. If you divided a negative 1 out of here, the x would become positive. And then if you divided a negative 1 out of here, that would turn into a negative. And we've learned that trick before, but again, it's tricky to remember everything when you're working on these bigger problems. But the beauty of that, and keep in mind, I'm still looking for the limit as x approaches 2. Now these cancel. And now I'm going to be good to go, because now I can go ahead and use direct substitution without getting a 0 in the bottom. The tops are negative 1 when you multiply them, and in the bottom I have a 4 and an x plus 2. So when I use direct substitution and put the 2 in there, I end up with negative 1 over 4 times 4, or negative 1/16. So when you go to see your worksheet, there's going to be a little bit of each of these. Not a lot, because obviously they take a little thinking and a little time. But come back to the video if you need to and watch the part that pertains to the question you're trying to do. And then you'll be a rock star. You'll be awesome. See you later. Bye, guys.